Honestly, half of it's just like whatever.
Oh, okay. I just.
Oh, it's bad.
So I guess it doesn't matter which end you're hitting it from.
Yeah. Actually, no. Now I remember. It's because I'm right-handed and it's easier. I thought it would be hard to figure out where your finger was if it was like.
Yeah, I see your point.
Further away from the edge. Sure. But the lasers are just these little guys, but they're in one of these 3D printed things so that I can adjust the angle.
And you have them up top.
Mm-hmm.
I figured they'd be easier to mount more rigidly than the bottom.
So I mounted. That might be true, but these I did mount more rigidly. But then, like, after a while, they just weren't pointing straight anymore, and it was super hard to get to the point of the sensors. And so these like aren't mounted rigidly anymore. They're like.
If you sneeze too hard, they'll be out of.
They stay pretty good, but you can like undo one of these screws and just kind of like mess with it to line it up.
Okay.
It's just too frustrating to keep trying to like unglue this little things and just like shove it over a tiny bit.
Did you do all
Question.
the wood stuff here? The woodworking stuff here?
Yeah.
That looks nice.
Thank you.
Why necessarily lasers?
Oh, well, this all came about because my wife and I visited the Meow Wolf in Santa Fe, and they have a laser thing there that works kind of like this, but it's like to the ceiling.
Sure.
And she was like, I'd love one of those, and I was like, I bet you I could figure it out.
Well, I mean, from the ceiling, a laser would make sense because you need to be able to hit the thing.
Yeah.
But what I was wondering here, if lights, you could avoid the adjustment problem. Is all I'm.
I was thinking about just having one. Yeah, if there was like an LED strip of just like white light, that probably would work too.
Yeah, well, you can get some really super bright LEDs these days, and I was just thinking that if you were careful about how you mounted them, since it's like a tube, so that you don't have side.
Yeah.
Then it should be easier to tune, I would think. I don't know.
You would want to use a colored light, not white light, so that you can tune your sensors to only look for a given color.
I doubt my sensors they're the cheapest thing that I could buy. I feel like, I don't know, yeah. The other thing is I got this little like ultrasonic mister thing because I wanted to put it somewhere near so you can see the lasers. I think it would look cool. I don't have that yet though.
Oh no!
So I want to put some fog in there and see if it looks cool.
Now the question is how do we prevent the fog from distorting what you're attempting to play?
I keep it light. I should hire somebody that like vapes to just stand by me. Float in there.
Yeah, I got my 16-year-old kid here.
Hit the jewel.
Frickin' vapors.
All right, well, you guys ready?
Yeah, here, I'll sit down and strap in.
Sick. All right, so I kind of wanted to just go through like my design process so that I can maybe give you guys ideas, and then we can all make cool instruments. So gonna keep it really simple and basic and not go through the harp stuff. So basically, my first thing is figuring out what to make. Pretty easy. You probably have an idea of what cool thing you might want to make. So what you got to figure out is what the inputs are and what the outputs are, because that's going to determine what components you need to buy. So inputs would be pretty much anything like sliders, knobs, buttons, switches, light, GPS coordinates if you want. You can get all of these modules that you can hook into something like this and turn into music. And then output's usually pretty simple. It's usually just audio, MIDI, CD, maybe like display, like this little OLED. So, just a couple really simple examples. You want to make a little USB controller, or USB MIDI controlled drum pad. 16 buttons would be your input, a slide pod, and a couple of push buttons. Just another really simple example. Maybe you want a little MIDI controlled synth module that you pump MIDI into and that it gives you stereo audio out. So the inputs would just be a MIDI port, an XY joystick for modulation control, and the outputs would just be a couple of TRS jacks and an OLED screen to look at patch data or something. And this is just a bunch of screenshots from this website, Adafruit, which makes a lot of modules and sells a lot of components. But just to give you some ideas of the kind of stuff that you could use instead of, say, like a photoresistor or a slider or a knob. They have a ton of really fun looking stuff. They have flex sensors. I don't have a screenshot of this, but they have like muscle sensors that, like, if you flex, you can control stuff. Like heartbeat sensors, all kinds of fun stuff. So now that we know what the inputs are and the outputs are, we need to pick the platform. So what is the brain going to be? So in this case, it's a teensy, but it doesn't necessarily have to be. There's a million different microcontrollers that you can use. But before we go into that, we should talk about the different types of inputs. So you've got two types of inputs that we'll talk about for the purpose of this: digital and analog inputs. Digital would be something like a button or a switch, just things that have two states, so it's either on or off. And in real life, when it comes to this stuff, it really just means like 0 volts or 3.3 volts, like the minimum or the maximum. In reality, it's probably something like anything over 2 volts will be considered high, and anything under that will be considered low, but you don't usually have to think about that stuff. It's just switches on, it's high, switches off, it's low. And then you got analog inputs, which are more interesting. So these will give you a value between, say, 0 and 1024 in this case. That's not always the case, but basically, you know, if you're turning a twist pot, you can take readings between 0 and 3.3 volts, and then it spits out a number that you can do something with, like change the volume or whatever you want. So yeah, so the reason that matters is because the platforms have different numbers of analog and digital pins available. So I've got one of these little like Arduino Unos, and you can see all the little like pins on it. And you can't see it from back there, but if you read the little things, you can see like A1, A2, A3, and like D1, D2. So those are like the analog and the digital inputs, or digital pins. So it really depends on the platform, how many exist of each. So if you know you want 10 sliders that have an analog output, then you're going to need something with at least 10 analog pins. So that's the big thing. And then, yeah, power, price, and just like community and available examples if you're getting started.
I was going to go on the price thing there.
Yeah.
ESP32, if you're looking for faster processors, ESP8266 are dirt cheap. I mean, a couple of bucks a piece type of thing. And one of my favorite ones these days is the Raspberry Pi has an Arduino equivalent. I forget, what is that thing called? Pico. And it's more pricey than that, but it's generally cheaper than Arduino. Arduino is really expensive.
Yeah. I haven't tried the ESP32s yet, but I haven't done anything Wi-Fi. And
Well, that's the other cool thing. It handles Wi-Fi, and some of the Raspberry Pi Picos, if you get the right model of it, has Wi-Fi in it.
Yeah.
ESP32s also do Bluetooth, if that's something you're interested in.
Sweet. Yeah, I really want to mess with those. These are the two that I usually use. Basically, it's just the Teensy is great for audio stuff, real-time audio. One of the big benefits of the Teensy is there's an audio tool online that you can kind of use to construct a synth, and it just exports some code to give you a starting point, which I'll show in just a sec. But really, it's just so use the Teensy if I need a lot of power and things need to be fast and it's dealing with the audio. And then the Raspberry Pi Pico I'll reach for if I'm doing something like a MIDI controller, a macro pad. So like these are some old things that I built with Raspberry Pi Picos. This one just, I don't even know what it does. It sends something to my work computer to open different programs, but I never really used it. I kind of just made it and then was like, I'll just type in the name of the program instead. And this is also built on a Raspberry Pi Pico. I think it's also a macro pad. It looks like I tried to split it open to get it out for something else and didn't succeed. but this could be like a drum pad. It'll work pretty well. Okay, so now just come on, you can do it. Okay. So I just have a really simple hypothetical example, just in case you've not messed with any of this stuff before, just to show like how things are actually wired up, because it's not. It looks a lot more complicated than it is. It's just learning a bunch of individual little steps. So this hypothetical microcontroller only has 4 pins on it: power, ground, digital input, and 1 analog input. And let's say we're gonna make a device that's like a single button MIDI controller. You press the button, it sends a note message with a certain velocity. And the velocity you can control by a slider. So 1 button, 1 slider, that's what our thing is. So there's a slider in our button. The button's really simple, it only has 2 pins on it. The slider has 3, the voltage, the power, the ground, and then the output. So the ground and the power are pretty self-explanatory. You just connect those to the ground and the power of the microcontroller, and then the output you'd connect to the analog pin. So something like that. The button is the digital input. It's only on or off, so that we can just connect to power and to the digital pin. When you press the button, it lets the power through to the pin, and it says it's on. The button's been pressed. So then the next thing would be to figure out what logic to use. So really, we just want to keep checking the value of the button. If it's on, check the value of the slide pot. Normalize the value of the slide pot into something useful, because the analog inputs, you're just going to get a number. For example, like 0 to 1024. That's what these slide pots in the back return. But MIDI velocity is 0 to 127. So take that number, normalize it to something between 0 and 127, and then send the MIDI note. So the code would look something like this. Basically just doing that, but code version. You read the button. If the button is on, if it equals true, then keep going. Check the slide pot, the value of that. Normalize it to get an actual MIDI velocity, and then send the note. And then after that, it just keeps looping around and just keeps doing that over and over again. There are some caveats with like buttons. For example, this one, if I actually were to run something like this, the Teensy or whatever microcontroller runs so fast that if I press the button, it would say that I pressed the button like 1,000 times, because I can't press it faster than it can loop around. So you'd need some additional logic to check and make sure that you're getting the press that you want. But basically, that's all there is to it. So the laser harp. This was the first laser harp that I designed, and it's all 3D printed. A little bit janky, but it worked for the most part. But for the 2.0 design, this one, I had a couple of things that were must-haves. I wanted more strings, a dedicated photoresistor for modulation. For this one, only one of these photoresistors actually had an analog output. That one you could use to like modulate the filter frequency or something by putting your hand over it. This one, all of the photoresistors are analog, so these I used little modules that I got that just kind of did all that stuff for me and just said on or off. But these I'm doing all the logic in the code. Adjustable aim lasers, because those getting out of whack was really annoying, and repairable, so you can actually take both of these panels off really easily by unscrewing these to get to the inside. And that it looks cooler than that, which I think so. Just yeah, some of the differences. That's super interesting. Side by side. All right.
How hard is the difference between USB and wall?
It wasn't that hard. It's really just making sure that microcontroller, like what voltage you can give it without frying it.
Okay.
So the Teensy, for example, is 5 volts. Went to the thrift store and found a power supply that was 5 volts and like enough amperage to run all the lasers and the rest of the stuff. So it was pretty easy. And that was one of the reasons that I did that, is because I was getting really close to the power limits over USB with the Teensy. So I thought I might draw too much current if I were just to only go USB, since there are more lasers this time.
That's another thing about using Nickel instead of lasers. Surely the laser takes more power.
Yeah.
But I think.
I don't know either. They ended up taking less than I thought once I added whatever value resistor I ended up putting on there. So I didn't need it to be like super bright, but yeah. If I was gonna run some battery or something, I might reconsider. Alright. How it works, you probably can guess, but basically you've got these photoresistors and they're taking readings from the lasers, and they're generally high readings because the laser's really bright. And when you put your hand in front of the laser, it takes a low reading. So each of those is an analog signal, so it's some number between 0 and 1024. Those, because that's so many analog inputs, the Teensy might have had enough for that, but I didn't want to solder all the wires to the Teensy, and I also had these multiplexers I wanted to use. So those 14 analog signals go to a little submodule that I made in there that has 2 analog multiplexers on it, and those are basically just a device that turns 1 analog input into 8 each. You can get ones that I think can turn 1 into 16, but basically it's just a switch that just switches really quickly between 8 inputs and then feeds it to the Teensy. So now the Teensy only has, these are only taking up 2 pins, 2 analog pins for the Teensy, even though there's 14 lasers. So those go to the 2 analog multiplexers. The Teensy sending signals back to the multiplexers that basically just switches which input it's looking at. So, 10,000 times a second, it's switching between each of the pins of the multiplexer and taking a reading. So then we store those readings in an array that looks something like this. So using that example of those 3 lasers where the middle one is blocked with the hand, we might get readings like this. So the one with the laser hitting it is 890, the one with the hand in front of it's 150, and then the last one's like 800. They're all like a little bit different just because of the variance, like the tolerances of the components, and then all these holes aren't exactly the same, the lasers aren't hitting exactly the same. So we get the raw values and then compare them with the threshold. Let's say it's like 400. Right now this is hard-coded. So the middle one is below the threshold. So that one is, I feel like I did this array the wrong way. Alright, pretend the middle one is not the middle one, it's the first one. This hand is in the first one. So the current status is, oh no, I see what I did. I'm sorry. Alright. So basically we're just turning those raw numbers into an on or off, right? If it's below 400, it's off. If it's above 400, it's on. And then we also have to save off the previous status of the laser, because the way that I designed this was that when you release the string is when it makes the noise. So it's not triggering when you put your finger in front of the laser, it triggers when you do that and then take it back out. So we have to know the previous state of all of these two. So basically,
One sec. Can you play more than one note at the same time? Oh, wow.
yeah,
So how many voices do you have?
14.
14 individual voices.
Yeah. Yeah, the Teensy's great. It's like, I've not ran into any limitations yet for what I've built. So yeah, basically just if it was blocked before but now it's not, then play the note. That's the logic. So these are some like concept sketches that I started with. Just some build process pics. Figuring out the angles so that I could go into the wood shop and cut these things so that they would fit together. Some more stuff. So on the left, that's what these front panels are made out of. It was just some scrap walnut that I had that I filled the cracks in with black epoxy and then planed it and sanded it and all that fun stuff. The thing on the right is the multiplexer module that I mentioned earlier. So that's the thing that turns 14 inputs into 2. And then the actual voice or signal path. This is an example from the Teensy audio library, which I'll just open the browser here. So this is one of the nice things about the Teensy is that it gives you all of these audio objects, inputs, outputs, mixers, synths, effects, and you can just kind of drag and attach them. And if you click on them, it tells you the functions that each of them have. So in the code, if I wanted to change the gain of a mixer, then I would use this function. And then if I click export, it basically just exports all of this and I can paste it into my code editor. It doesn't do any of the logic stuff, so it's just handling the voices. Like when I tell it to play a note, that's kind of when it gets to this stuff. But it's super handy and you can do a lot of crazy things. Okay, the future. So it has MIDI out. It doesn't do anything yet though. I basically just tested that the MIDI port works, and it does, but I haven't done any coding to actually send MIDI notes. It should be relatively easy. More voice types so that you can play things that aren't just the string sounds. So like in the Teensy audio library, we've got all these types of synths, drum synth, wavetable synth, a whole bunch of stuff. You can also do sampling. So basically I just want to make it more flexible. This old one had some other modes that I haven't implemented in this yet, like an arpeggiator, where if you like held 3 strings down, it would just play them. Auto calibration. So right now, as I mentioned, the threshold for the photo sensors is just hard-coded into the code. So if I take this in a different environment, like out in the bright light, it probably wouldn't work so well. So I did have an auto calibration thing for one of these things that I think I could port pretty easily. Basically just keeps taking readings for a few seconds, you put your hand over it, try to get it to the high and low values in the environment that you're in, and then it can use that to normalize the sensor values and figure out the threshold. And then the other thing about the Teensy that's nice is they sell these audio shields that basically just, you solder the thing right on top of the Teensy and it has a whole bunch of inputs and outputs right there for you. So like this aux in, I didn't have to do anything, it's just part of the audio shield. And there are pins that make it really easy to put microphones in, 1/4" TRS jacks. So like this is another thing that I built that has a bunch of inputs. So yeah, just having more inputs, maybe I could do like a vocoder thing, you know, have a mic input. And then yeah, some sort of like water atomizer thing, something to show the lasers, because I think that would make it look a lot cooler. And I don't want to use a big old fog machine, but if I have to, I'll do it. Maybe. Yeah, I did make the lasers replaceable because they are super cheap. Actually, pretty much everything is just AliExpress components. I've had pretty good luck with them, and they're like 10 times cheaper than not AliExpress components. So if you go that route, just order like twice as many as you need, and you'll be good. But I don't trust the laser modules won't burn out, so I made it pretty easy to desolder each of these and just replace them with a new one. And yeah, these sliders don't do much. One of these is volume, but I think it's kind of not really volume. Like, I think it's only the volume of the not reverb signal, so if you turn it down, the reverb gets louder. They gotta fix that. This one is gonna be an FX one, which you can map to different things, like reverb or delay or something.
For your future listening, if I understand, I've never played a harp, so my
Yeah.
understanding is those pedals effectively let you chord,
Oh.
and that might be an interesting thing. It would be easy enough for you to have an input that would cause only chording
Yeah.
that imitated that. So
Yeah. That would be cool. It's a good idea. Foot pedal controller.
the other thing is, it looks like you ran out of strings. I'll tell you how old-fashioned keyboards work. There exist, my understanding is, chips that will do a similar effect to this, but let me explain how the keyboards work. You had a key, and when you pressed, effectively it went two places on a grid, so it completed, that button completed two places. So the decoder chip for that looked to see in two places and decoded to that key press. Okay, and so what that means with this is that you don't have to have, you can have a square root of number of connectors.
Oh.
Okay, so like 4x4 to get 16, you get the idea.
Like a matrix.
A matrix, exactly.
Like diodes.
Exactly, but and you're checking that. In order to do it, you might end up having to use interrupts, though.
Okay.
Polling is not going to work well with that approach, possibly. But at any rate, there's no reason why you couldn't get to 1,000 if you wanted to.
Yeah.
At some point, you're going to run into some physical limits, but the point is, CAPS 14 could easily.
Yeah. That's a good point. Yeah, the nice thing about those multiplexer chips too is that each of them, you have to give control signals to select the input, but those control signals, the same ones, can be sent to 100 multiplexer chips. So you only need 3 digital outputs to control 100 multiplexer chips, and then each
That's
of those.
the way a lot of the buses are working. You know?
Yeah. Yep.
So at any rate, I just, because you've obviously hit it's going to be hard to find chips that handle more than 14 the way you're doing it.
Yeah. 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 Any questions, or feel free to come mess with it. Also, I can open it up if you're interested.
Yeah, I want to see how bad your wiring is.
Oh man. I also have some random components that were used in this if you're curious.
Pop and why you still can't. Not looking.
One thing I learned is that encoders are way better than potentiometers, and they're pretty easy to use. Basically, a potentiometer is like an absolute position. Like it's as you turn it, it's an analog output. The encoder, you can just keep twisting around and around forever, and it just outputs numbers. So you just kind of count.
Nah, come on.
Just short it out.
I want to watch.
That good. Oh, actually, hold on. I didn't show you this other photos thing that.
Oh, you can make a harp theremin.
Exactly. So right now, let's just map to the filter. I should probably use some sort of logarithmic thing because there's only this much room where it actually makes a difference. But idea is you could go in here and map that to different things, reverb, delay, whatever you want.
Is it triggering audio files or is that
It's based on that teensy audio library. So they've got one that is a string synth, basically.
almost all
Alright, this one doesn't have much on it. It's just that photoresistor. And then this one's got most of the fun stuff. Lots of hot glue because it was the easiest thing to do.
shrink to
I've got some on there. But yeah, it's it just got worse and worse, this mess. So now that's just what it is.
Hell
You only have a little bit organizer. But this multiplexer thing I was gonna mount somewhere. Huh. It's not plugged in. But I like
Got
made
some
the wires
RF
too
or
short.
interference or?
No idea. Yeah, I just brought some other random crap-based examples. This is a thing that just sends a MIDI CC message for a filter, but I use an old motor from a cassette deck. Basically backwards as a normal motor. Instead of you sending power to the motor and spinning it, it's the other way around. Just kind of silly. So yeah, think of some weird stuff and help you build it. Raspberry Pi Pico is a great thing to start with, just because they're $4, so who cares if you mess it up?
You will mess it up. I guarantee that. Just so order more than one.
That's right. The other thing that's nice about those Picos is that this might only be true for Circuit Python, but basically programming them is super easy. Like, there's a way to do it where you just drag and drop a file, and the file's just called code.py or something. Instead of having to get some other software that can like compile and upload stuff. But yeah.
Yeah, if you're not used to coding in C, by all means, please use Python.
Yeah.
The other is, it's made for professional programmers. It just is hard to, and it'll be a lot harder to debug and so on. You really need to stick with Python if you're not programming.
Yeah.
How much code did you actually have to build outside of the stuff you imported from the TC stuff?
I don't know. Like 1,000 lines or something? There we go.
So this was basically, you had to code the logic around when the things would be triggered.
Yeah, exactly. So if I go to this inputs, audio setup. I need to make this sound look so bad. Okay, so the audio library, this is what it gives you. Everything else I had to write. So yeah, it does the hard stuff, like making a string sound. Like I wouldn't know how to do that from scratch, but you got to do all the logic. And yeah, I think this probably was my first C project. Yeah.
Sweet. You gonna perform it?
No idea. I've never even seen a harp in real life.
Was there a limit to what the length of the laser can be? So like say you made one that was that tall, is there like to where it loses sensitivity or does it not matter?
I mean, with these there's probably a pretty short limit just because the lasers are so weak, but I'd imagine if you got a strong enough laser, basically you just need like as much contrast as possible between light and dark hitting the sensor.
Undirectional. Light has to be hyper-directional.
Yeah.
Instead of something that just blasts out like that, that's useless. It
Yeah.
has to be like that.
Yeah.
Because if it's a bunch of lights that go like that, then there's no definition.
Yeah.
I'm not sure this will work with lasers, but it definitely would be for light bulbs, or the LEDs. I mean, consider just a very thin sheet of something that is opaque, so that if you wanting to do
Just like a
see the
thin line.
things, yeah. You know,
Sunglasses.
I guess the other thing, you could fake it in the sense that you have two different sets of lights. One goes into something to show off the light when it comes down. The other is where you strut.
That's true. Yeah.
I mean, it's a little bit cheating, but then, you know, who cares, right?
Just don't tell anybody, you'll be fine.
Yeah.
Just to avoid using lasers.
In fact, you can make the actual string lights then not be a color at all.
Yeah. Just infrared or something.
Yeah.
I feel like
Yeah.
a lot of people that make these want to use lasers.
It does sound cool.
You know, I think
Well, it sounds
like
cool.
half
Okay,
the
I mean,
point is like the fact
problem
that
is
it's
that
lasers.
lasers are precise, and that's not a good thing when you're dealing with
Sure.
non-precise positioning of sensor and receiver. And
Yeah,
I just was
yeah.
trying to avoid that tuning issue.
Yeah. Yeah, I also considered you can get these like I don't even know how they work. The distance things. You can just get these like sensors.
Ultrasonic
Yeah.
proximity
Yeah.
gizmos.
Okay,
Yeah.
there exists. I mean, there's several ways of doing it. One is ultrasonic, but you also have laser ones. And,
Okay.
pardon me?
Oh, like different types of the same like distance thing.
Yeah, each has, and you also have radio frequency ones, though that is really tricky. What it has to do with signal bouncing is the problem. But at any rate, the ultrasonic ones are cheap and very accurate in small distances. And so, like, if you wanted to make a different sound depending on how far you were down on the string, that would be you need another sensor there, but it would be possible.
Sure.
The distance measure with laser really would only work for that. It really is made for long. It bounces off. So any
Yeah.
surface that can reflect the light back, it sends frequency, an encoded frequency thing so that it can know that it got the right thing back.
Sure.
And that's how it knows how far things are. And it's very accurate line of sight for 200 meters maybe.
Okay. It's pretty long. It's
That might be a
probably
little
hard
longer.
left.
It definitely goes many tens of meters long.
Sweet.
I was working on a project with this at one point.
Oh,
And
sweet.
the problem is it was also with robotics, and that was the part that fell down. The sensing and the distance measuring were working fine. The other way you have, if you're talking about really long stuff, you can use GPS. The GPS chip, you know, the little plug-ins
Yeah,
you get
yeah.
with that. The programming of this is difficult because
Yeah.
in order to get it truly accurate, you need to like get 5 satellites in range, and it won't work like in this building.
No.
So
Yeah.
that's the other distance way.
That sounds cool.
Yeah.
And this one, one of the other parameters of this is that all the components should be cheap because I didn't trust that I was gonna make it work.
So that's a question. How much did it cost you to put all this together? Total price.
So the TC is the most expensive thing by far, for sure, like $20. The audio shield for it's probably like $14. The wood was like scrap wood that I had from other projects, so like it was free for me, but I guess like
That could be expensive.
yeah. Well,
If you didn't
this
have
much-
the access to make stuff, I guess.
that's true.
Like if you had to buy something.
Yeah. So this was all like raw wood that I bought and then like milled in the wood shop over here because they have a planer and jointer and all that stuff.
That looks really good.
But yeah, the laser modules were maybe like 15 per dollar or something. Pretty much every other component was like $1 or less. So maybe like $50 or something. Yeah. And the Raspberry Pi Pico devices you can make for like you could make like a drum pad for like $6 probably. Just as long as you're cool with cheap components and like have a way to 3D print stuff, you can go hella.
How many hours did you put into this?
Are we counting this one? Because like I didn't know how to program in C before this, so probably a lot.
How much do you think for the second one with some level of bass understanding still?
Dude,
More than you want to admit.
I just don't know how to estimate. I feel like I did it like over time until like 2 weeks ago when I was like I need to finish this for this. Yeah. I don't know, like troubleshooting this stuff, like the electronic stuff, I'm still not great at. And like I'm still not really great at like soldering or anything. So like those multiplexer chips, I redesigned it like multiple times just because.
You've got that soldered, not breadboarded?
What was that?
You've got that soldered, not breadboarded?
Yeah.
Oh, okay.
Yeah.
I mean, there's nothing wrong with that. It will hold together better, but
I breadboarded some of it before I soldered it, but yeah.
Is there a reason you picked 14 or
I'm betting it has to do with the number of inputs you had.
No, it was.
He wants to play Twinkle Twinkle Little Star.
I think I really just wanted 12, and then I think I had a piece of wood that was this big, and I was like,
just did more?
how many can I fit?
So
I think it was just that.
Can you go up and down octaves with it?
Not yet. So this one had like dedicated octave buttons. This I'm planning on just having like a menu, like a screen menu, where you can just like twist the encoder or press the encoder or something.
That'd probably make it easier to perform, I guess, if you had an octave. It's the easy octave.
Yeah,
Because then you can hit it quickly, hit a note, hit it quickly again. So you're back to
yeah.
cool thing.
So, are you actually able to hit the note you want to?
I
I'm
don't
just
know.
curious.
I don't know yet.
Oh, okay.
I like pretty much have, this is what I've done so far.
Oh no,
test it.
there's nothing wrong with that. Like I said, with the chording, if you could get that, that would make
Yeah.
a potentially interesting thing. My understanding is one of the pedals on the harp actually moves a section of strings out of your way,
Oh,
and so when you're playing that, that's a chord of sorts. You know, like a
yeah.
guitar where you know. And I don't know how it all goes together, okay? But at any rate, the point is you could simulate the moving of the strings by just simply turning those lights off or
Yeah.
ignoring those lights.
Yeah.
You could see the pedal like holding an arpeggiator, or if you could do scale select on it and stuff. It'd be cool.
It wouldn't be a bad idea to just put a couple of extra ports for like analog inputs and just make it so you can like plug in a pedal, and then you'd have different pedals that have different input types, or I don't know. Yeah, that's a good idea.
The video that whatever was attached with whatever you guys sent to us, I don't know. Whatever I looked up that was attached to this stuff, the one that they had was like big, and the guy with the laser pieces were like, he was standing there like this. Did you guys watch that one? Did anybody watch that video? No, I don't know. It was like it kind of made it like make sense as a performance instrument in the sense that you could easily pick out pitches because it's very widely spaced. It was like this big.
Yeah.
And it wasn't that many strings, and he obviously had it like not chromatic, but you know attached to a scale that he was then like playing the melody with.
It's like having
Cool.
a bunch of thermins.
What's that?
Like having a bunch of thermins, like in a row, essentially.
I mean, it was a bunch. It was just lasers. It just looked like beams of light going up,
Right.
just like this, but expanded, right?
Right.
You know, and you're just like breaking the same thing. It was just larger.
More expensive
Yeah.
lasers.
Laser keyboard. There's a keyboard on the table and senses.
Oh yeah, right. There you go.
But that's just on and off, right? Because when you
You're basically just translating. Instead of using an analog switch, you're using just a glorified analog switch beam, break the beam, and it's just like a switch beam.
and it's like
So it's just like hitting the note. It's just like hitting the note or the string on the harp.
Right.
It's just
Okay.
sense is that. It's just like the projected keyboards for like a laser keyboard.
Uh-huh.
The gimmick thing that I never put on, but you could literally type,
You're gonna put
Right.
a built-in
and it had the same
speaker in.
accuracy as an actual keyboard.
right.
I don't know. Maybe.
Looks like you could fit it right below your
Like a QWERTY
sensor
Yeah,
there.
right.
Not
So, I mean,
Yeah.
it
Some-
was. They were
small enough
accurate
that you could
enough that
play
if
it
you could keep up.
It's
It
not a
would
bad
project.
idea. As
On
long
a
as I
couple
have
of
enough.
It
lipo
would,
batteries or
It
something.
registered every key press.
Sure.
I have. Yeah, I could do. Yeah, the batteries good
It's
idea
just a
too.
laser.
It took me a
Cordless
second to
tool
remember
batteries
what
is
you're
what I
talking about,
use.
but
I mean, it was
Which
a
one's
gimmick thing for
cordless
sure.
tool
Yeah.
batteries?
Oh, nice.
Sure, sure.
Okay.
You put like a drill battery
Just a little bit
right on the side of it.
No,
I'm
it's
using
a
Yeah,
my
yeah,
drill
right.
batteries.
If I'm just breaking it down, I'm
Powering my
getting
amp.
a room like
That's
this.
I
like,
don't
no,
have
that's the
power. That's You're a brave person.
So let's looking at your code. What's the end goal?
Since I broke my phone.
Just to make a laser harp.
Oh, okay.
You should play it for him. It's here. Turn it back on. It's,
I just kind of walked in, I was looking at the code and stuff. I'm like, okay, you got something interesting here,
Oh,
but
it's
I'm
just
not
showing
quite
you.
sure what it was. Just kind of trying to sit in and listen and kind of piece it together. And then I got your attention and asked.
Yeah, for sure. Yeah.
I wasn't sure. I thought at first this was a board meeting, but
Not quite. So I just broke it.
you take the screws too much.
Maybe. Is this still on? Yeah.
So does a laser shoot through the
Is the
through the
high
holes in the top?
pass filter on?
One time,
Yeah.
one time,
Pay attention.
He'd have been troubleshooting this
call,
thing for the
man.
rest of the night.
But at the
Well,
same
it
time,
was like it's kept the lighting.
the laser receiver, as he was saying, if you were to put holes directly up on top of those, the receiver or the sensor could sense the light going through the hole, and it would shoot the laser up to the top. And you could theoretically create his little thing he's talking about. Now you could play it on top.
Yeah.
You could if you got smart about it, but down here it would just make it look like everyone around you can see the laser beams being broken, and it
Sure.
just adds another level of
Yeah.
showmanship.
Yeah. Yeah, I'm still need to figure out some sort of like fog mechanism that's really small and like just enough to show the beams.
I don't know if anything. A fog machine though.
Just like this.
Just
Problem
a,
of it is, it's gonna really fuck with your readings.
Yeah.
I don't think a fog machine. I don't think.
I don't know.
No, because
Remember,
the
the smoke
sensor.
and fog is blocking the laser. That's how you
Well,
can see.
we're not talking.
Right.
What I'm thinking, I don't know exactly your layout, but in my head, if I were to design it, the sensor would be inside the hole, so it would be isolated from any other source of light. So as the laser goes through the hole, it's lighting up that hole. As you break the beam, there's no light going through the hole, so fog or not, it doesn't care.
Sure. Yeah.
He's such a
Now I could be
threshold
wrong,
on
and
it.
he's right.
Yeah.
But, you know, it's just one of those things you have to try. But it would be pretty cool, as he's saying. I'm just picturing all the lasers in the sky, and just
Yeah.
So if you're using the invisible lasers, you could actually tie another beam to it to kick on when it's triggered. In other words, the emitter would not only send signal to your processor, but it would also turn on an LED.
You're talking about an IR LED or an actual IR laser?
Well, I guess I'm an IR laser because
Okay.
he wants to be able to see it play. Okay,
Oh, it's like a-
but what I'm telling you, you don't have to be doing the light that way. You can have when the emitter triggers, it could then turn the light on in a place that.
Just an idea.
Yeah.
It's just a stupid idea.
Yeah.
From the idiot in the room, it would be really cool to have a blue laser, a green laser, a red laser, kind of alternate them, because then you would have different colors.
To be fair, green lasers are much more visible in warp conditions.
Yeah, but if you have fog in the air,
Yeah.
but then you have red, blue. I think they're yellow.
But a
I
green
don't
laser,
think so.
just a green laser
What's this one?
in a regular
Oh wow, there you go.
goes further than a red.
No,
It is limited.
very
You can
half
spot
finished.
on it bright light.
But
And a
on the
well-lit
same
room.
logic, though, if
Much
since we're on the
easier.
topic,
Yeah.
you
In
could
transit.
do RGB LEDs
Okay.
with optics when you create
True.
a focal point. Now,
The
obviously,
most that you
because of the
see is
optic,
when it
it's
hits the
gonna
target.
expand as it goes
But a
farther
green
away.
laser is
But you could do
visible.
red,
Is it triggered a filter?
yellow,
Yeah.
and they would all act the same.
I tried plugging it in before it came here and it like did not turn on, so I broke it sometime between the last time I used it and now. But it just
It would be cool you just hit it.
What is that? What is that?
this is just some goofy thing that I made with like a cassette tape motor that I got on a single machine. Basically, you spin it, it sends an analog like voltage to a Raspberry Pi Pico, and then sends a MIDI message out this MIDI port. So you can like plug it into a synth, and if you do this, it like opens the filter up or something.
Oh, okay.
Right now, it's hard programmed to the mod wheel.
Is this an Arduino workshop?
Kinda. So, you do a better job of explaining than me, Jay.
We're just a bunch of synthesizer nerds. We've been doing happy hours for a few months, and
Okay. I kind of walked in,
Then you start
so
making
she was
it.
working on the laser and saw this, and like, oh shit, I walked in on board. So I went out and took a phone call for work, and I came back in, I'm like, okay, I gotta get these emails put together. I just came down here to work, and it's quiet. And I started looking at your code, I'm like, wait a minute, this isn't a board meeting, what are you doing?
Yeah.
Yeah.
We're gonna do these monthly here of some sort of thing.
Is this like, did you guys announce this on Slack, or is this just kind of
I think
in the know thing?
It's on the calendar.
It's on the calendar, yeah.
Well, it shows
It's
what I
on the
know.
meetup page,
Oh, I got it because I'm signed up for the Makerspace.
I'm not
and
very-
it's on all our newsletters.
I'm not smart enough to look at any of that.
It was only up a few days ago because we got approved on this like this past week. I joined like a week ago.
FYI, there's a lock picking class that I'm teaching at the end of the month.
Oh, sick.
Just
I'll attend
since
that.
you're
It might be a
obviously
lot.
not paying attention to our newsletter,
Are we gonna demonstrate how crappy master locks are?
I think that's self-evident.
Not everybody knows that. but
Understood.
Are
My
you
dad
gonna
had
do
my
that?
dad. My dad had a master
Welcome.
lock
Thank you.
on his car trailer, and I went and picked up a zip tie.